Hi there, welcome to my channel Mandu to Fundu. In this video, I'm going to discuss about the solution for finding the average of levels in binary tree problem. Let's look at the problem description. We are given a root of a binary tree and we have to return the average value of the nodes on each level in the form of an array. So for this input, for this level the average is 3, just only one element. For this level, average is 9 plus 20, 29, so 14.5. And for this 15 plus 7 22, so it's 11. So the final output will be 3, 14.5 and 11. We'll see how to solve this problem. So we are given this tree and we have to return the average of this level 1 and this level is 2.5 and this level is 4.5. So that is the output we have to return. We have to do the level order traversal on this tree. As we do the level order traversal, we add all the elements we traverse in the inner loop and add them up. And after exiting that loop, we divide that total sum by the number of elements and then add that average value to the output list. This is just an extension of that level order traverse algorithm. Let's look at the flowchart. Input for this procedure is pointed to the root node. First we initialize the output list. Then we check whether that root is null. If so, we return the empty list. Otherwise, we initialize the queue and add the root node to that queue. So the queue will have only one node. And there will be two level of loops process the queue. So the first outer loop checks for queue is empty or not. If so, it will return the out list. Otherwise, it will initialize the variables total, count and index. So count will be set to the number of elements in the queue at that point in time, and the index will be set to 0 and the total value is also set to 0. Then we enter the inner loop where we check the index is less than count. If so, we proceed and dequeue the first element and add the value of that first element to the total variable. And we check whether any left child present. If so, add that left child to the queue. If there is a right child present, add that right child to the queue. Otherwise, continue with the next iteration without doing any addition. So the index value will be increased. So the inner loop will run until all the count number of elements are traversed. So once we come out of this loop, we have the sum of all the elements in that level. Then we divide that value by the number of nodes in that level. So we get an average and add that average to the out list. Then we proceed to the next iteration of the outer loop. We check for queue empty. So when we reach the leaf nodes in the tree, we will be hitting these conditions and we come out and then we return the out list. Let's move on to coding. First I initialize the output list. Then I check whether the root is null. If so, we will return the empty list. Otherwise, create a queue and add the root node to that queue. Then we enter the outer for loop which process the elements level by level. So here I initialize the total variable to 0. So for every level it is initialized to 0. At the end of this iteration we compute the total sum. And then we initialize the count. We take the total number of elements in the queue right now. Then we process the count number of elements in the queue. First we dequeue the element from the queue and then update the queue. Then I add that current node's value to the, then now I added the current value to the total. Then if there are any left or right child, add that node to the queue. Then once we come out of the inner loop, I compute the average by dividing the total value by the number of nodes in that level, which is present in the count variable. Then I added that value to the out list. And finally I return the out list. There is the typo, so I fix it. Next I am going to run the test cases. Okay, all the tests passed. Next I am going to submit this program. Cool, it's accepted. Next I am going to do the code walkthrough with sample input. We have this input tree and the expected output is 5.0, 2.5, 4.5. So to begin with, we put that root node in the queue, so as we do here, and we check whether it's greater than 0, and then we enter the loop and we check the current number of elements in the queue, which is 1. So then the inner loop will iterate over all the nodes, in this case only 1, so we add that value to the total and then we check whether it has so the total value will be 5, and then we check whether the current node has left child. Yes, it is 1, and then it has a right child 4, so we add those two values in the queue. And once we come out of that loop, what we are doing is dividing the total value by the number of elements in that. So in this 5 divided by 1, 5, so the output list contains only one element, 5.0. In the second iteration of the outer loop, we see 1 and 4 in the queue. So the inner loop, the total value is initialized to 0 and the count is 2. We are entering the inner loop, and as we see each element, we keep adding it. So 1 plus 4. At the end of this inner loop, we have 1 plus 4, and when we process the node 4, we add 3 and 6 to the queue. So that's why we see queue has 3 and 6 and the total value is 5. And then once we come out of the inner loop, we divide the total divided by the number of elements, which is 2 here. So 5 divided by 2, 2.5. The third iteration, q has 3 comma 6, so total is initialized to 0, and the out list has 5 comma 2.5, and it has total number of elements in the queue is 2. So the inner loop process each node, add them up, which is 3 plus 6 9, and then there are no childrens, so nothing is added to the queue, and when we come out of the inner loop, we divide the 9 by 2, so we get 4.5. So that will be added to the out list, and then we go and check the queue is empty, so we are breaking out of the outer loop, and finally we return the out list. Next, I am going to do time and space complexity analysis for this solution. Okay, let's use this tree for our time and space complexity analysis. So in order to compute the average of all the levels, we have to traverse the entire tree, all the n nodes we have to traverse. So for example, in the level 0 we have 1 element, level 1 we have 2, level 2 we have 2 elements, totally 5, which is the total number of elements. So the time complexity is order of n. So next let's see the space complexity. So if the binary tree is complete binary tree where all the nodes have 2 childrens, for the tree with the height 0, the queue data structures we use needs space for 1 element, and a tree with the height 1, the queue needs space for maximum 2 nodes, because we process only one level at a time, so maximum 2 is enough if it is level 1, height 1, and if the height is 2, then it needs maximum 4 nodes. So if we extend this, the tree with height h, the queue needs the space for 2 to the power h, so this is nothing but log n, so it's order of 2 to the power log n. So in addition to that, we have to return the out list, which contains as many number of elements as the number of levels in the tree, so which will be the height of the tree plus 1, so log n plus 1, and so the total complexity will be the sum of the space required for the queue data structures and the space required for the out list data structures, which is order of log n plus 2 to the power log n. Thanks for watching this video. Have a great day.